welcome to the school station. Today's video is going to be about changes in energy stores in the unit Energy and Energy Resources. This is from the AQA GCSE Physics 9-1 grading system. Today's video, I'm going to be talking about changes in energy stores, including the main types of energy and also what you might need for the exam. Let's get started. So the first thing that you have to know is we have to actually relate this to our real life. So in real life, we use different types of vehicles every single day. For example, cars, buses, trains, and even things like ships. These vehicles actually have things inside them that they store, which are called fuels, and these fuels actually allow them to move. These fuels have chemical energy inside them, and that chemical energy gets transferred into kinetic energy for the vehicle to actually be able to move. And since it is the 21st century, we also now have things like electric trains, which basically don't have to really store the fuel inside them. They actually just get the energy transfer from fuel in power stations to the train. So what we really have to think about is that in normal vehicles which contain fuels inside them and they store it as chemical energy, it actually gets transferred into kinetic energy. And just like that, also for electric trains, they get the electricity from the power stations as the fuel, and then that electrical energy actually gets transferred into kinetic energy for the vehicle to move. However, we also have to think about all the other things that the energy is being used for. Not only does the train move, it also makes a lot of sound. So a lot of sound energy is getting released, and this is known as dissipated energy. And also maybe there is some other types of energy that is being wasted, and that's dissipated energy. Something you really have to think about is dissipated energy. It's really, really important. So now that we know that everything that we have is every type of energy you put inside, it will always release into our useful energy and our dissipated energy. Now we can actually talk about the types of energy that there is. So the types of energy that there is actually there's 10 types of energy, and we can actually remember this with the acronym. Most kids hate learning GCSE energy names, and this we just have to look at the capital letters in this sentence like MKHLGCSEEN, and we will be able to know which are the main types of energy names. And this acronym will be really useful if you're trying to remember the energy names during your exam. So M actually stands for magnetic energy, K stands for kinetic energy, H stands for heat energy, L stands for light energy, G stands for gravitational potential energy, C stands for chemical energy, S stands for sound energy, E stands for elastic potential energy, and then energy E and the other E stands for electrical energy, and N stands for nuclear energy. And these are all the types of energy you have to know, and you have to know where they take place. For example, kinetic energy happens when something is moving, like the vehicles we talked about earlier on, and heat energy comes, let's say, when you have a light bulb, and when you actually turn it on, you're using some of the energy for light energy, but some of the energy also turns into heat energy, so that's dissipated energy over there. So now that we know our types of energy, the next thing we have to think about is the law of conservation of energy. So as I said earlier, you can see this diagram over here, and this light bulb has electrical energy, which is 100 joules of electrical energy, and the output is that there is 60 joules of light energy, but then there is also 40 joules of thermal energy or heat energy. And the reason why is because if you you can try it on, but make sure you're careful. If you've ever touched a light bulb when you've actually turned it on, you will see that it's a bit hot, and that's the thermal energy that's coming out. And as you guys can see, 60 joules plus 40 joules from the output is equal to 100 joules. So the electrical energy that was put into 100 joules, the output is also always going to be 100 joules, because energy cannot be created or destroyed. You're never going to see that the electrical energy was 100 joules and you get out 99 joules. It has to be exactly 100 joules as an output as well. So energy, whatever you put in, it has to be exactly the same in the outside. So energy cannot be created created or destroyed. It is just changed from one form into another because, electrical energy turned into light energy and thermal energy, but in the end, there is still 100 joules of energy. So that's basically what you have to remember, law of conservation of energy, that energy cannot be created or destroyed. So now that we know about the main types of energy and how it transfers in a daily basis, and also that if whatever you put in, how much energy you put in, it's always going to come out the same amount of energy. Now we can talk about some flow diagrams. So we just saw our our light bulb, obviously, with the with the 100 joules of energy going in and the energy that is coming out. We can actually represent this using a flow diagram, and this is what I have over here. So this is actually showing you guys again a flow diagram of the torch bulb. So instead of actually having to draw a light bulb and then writing down 100 joules and then 60 and 40 joules, you can actually draw it as a flow diagram over here. So over here, you guys can see that it starts off with the input, and the input to the torch bulb is, the light bulb, is actually that chemical energy is stored in the battery, and that's what you have to really remember. And then after that, it turns into electric current, and then it actually goes through the electric current in wires, and then the energy transferred, and then there is energy transferred into the surroundings, because when you turn on the light bulb and it goes through the wires, some of the energy that comes out will be light energy, but some of the other energy is actually transferred into thermal energy. So these are the two types of energy that come out. One is useful and one is dissipated. So that's the flow diagram, and you can draw it like this during your exam. So now we actually have found out about all these very useful facts. Now we actually have to think about how is this going to help us in our real life. Now we already know that there are so many types of energy, and if you have you ever been, I'm pretty sure everyone has been maybe in a shop, and we see all these different types of light bulbs, and every single light bulb is efficient in different ways. So what you have to do is you actually have to calculate how efficient it is, and basically you have to see how much is your money actually being used properly. So for example, if you have a light bulb which gives in 100 joules, but then it actually gives only 40 joules of light energy and 60 joules of heat energy, you're not going to want to get it if there is another light bulb that gives out 60 joules of light energy and 40 joules of thermal energy. So you want to get the more better one, the one that gives more light energy than the heat energy, because that's more efficient. So the formula we use to actually calculate the efficiency of any product in energy is useful energy out in joules divided by the total energy in joules. So if, let's say, again, we have this light bulb and we have it 60 joules of 60 joules of light energy, and it's 100 joules that we put in altogether, we can just find out the percentage, and that's going to be how efficient the light bulb is. So here is the working out that you would do in an exam. So if we want to calculate how efficient this light bulb is, we would use the formula. So it's really important to write down the formula during the exam. Don't just put it in your head, put it all down in a piece of paper, and then you want to go on and put 60 joules over 100 joules according to this diagram, and then you're going to get 0.6, and if they ask you for the percentage, all you have to do is times 100 and you will get the percentage of how efficient it is. So for example, this light bulb that you guys are seeing over here, this is 60% efficient, which means that it's pretty good. But obviously if there was, let's say, if there was a cheap light bulb with 90% efficient, obviously you would want to get that. So that's how you calculate efficiency in products. So now I hope this helps you guys about energy, and this is the overview about what we have learned today. So things that we learned today was obviously the 10 main types of energy, which was obviously, we can remember by the acronym. Most kids hate learning GCSE energy names, so if you just remember the acronym, I'm pretty sure that you will remember all the energy names. The second thing we learned is the law of conservation of energy, which means that energy cannot be created or destroyed. It can just be transferred transferred from one form into another. So, you know, electrical energy, if you put 100 joules in, it's always going to come out as 100 joules, maybe 60 joules of thermal energy and 40 joules of light energy. It will always come out as 100 joules if you put 100 joules in. We also learned the energy efficiency formula, which is, you know, useful energy out divided by the total energy in. And the efficiency unit is, there is actually no unit for efficiency because joules cancel it out. So if they ask you what is the unit of efficiency, there is actually none. So when you put your, like, you know, your answer, it's either going to be 60% or 0.6. There's not going to be any joules or anything like that. And last of all, we also learn how energy is transferred. Obviously, there is also always going to be a dissipated energy when there is a useful energy. So I hope this helped you. Definitely give this video a thumbs up and subscribe down below if you want more maths and science lessons from this channel, and also stay tuned so that we can show you guys more physics lessons and other maths lessons as well. Bye!